To start off with, we're going to do a little warm-up. These are two calculator questions. So I want you to solve for theta between 0 and 2 pi for those two questions. And you can do this as far as space goes on, you have space at the top of page 573, or maybe you want to do some on the column on 572. So you can solve these questions there. So for the first one, get sine by itself, you get negative 2/3. It's frozen. Oh, there we go, it's just slow. And then you find your reference angle by doing sine inverse of positive 2/3. Remember, your reference angle is always found as if it was an actual triangle with positive values. And once you have that reference angle, you know that sine is negative in quadrants 3 and 4. So these will be the answers that you'll get using that reference angle in quadrant 3 and 4. Notice I didn't draw triangles this time, because once you have practiced them more and more, you're able to find that reference angle and find your answers without actually drawing the triangles. But if it's still helpful to say, okay, sine is negative, so I know I have an answer in quadrant 3, and I know I have an answer in quadrant 4, label your reference angles. And because sine is opposite over hypotenuse, you can label those values on those triangles and then find that reference angle to be 0.73. And those diagrams might help you say, oh, I have to go pi plus 0.73 to get 3.87, because that would be this angle. And I have to go 2 pi minus 0.73 to get this angle. So for our second example, again, can get tan by itself, which is negative 3/8. Find our reference angle by doing tan inverse of positive 3/8. And then tan is negative in quadrants 2 and quadrants 4. So those are your two answers that you would get. Now, two more warm-up questions without calculator. So here are two questions without calculator. I'm going to just erase this for now. Calculator ones. Solving for cos. It's frozen. There we go. Thank you. Solving for cos will give you cos theta equals 4. You have to be able to recognize that whenever sine or cos is a fraction bigger than 1, remember, cos is adjacent over hypotenuse. That's not possible. You can't have the adjacent side larger than the hypotenuse. And so you see cos of theta equals 4. It's bigger than 1, so you write not possible. And that's why this is a non-calculator one. For part D, first you would have solved for tan, and you got negative 1 over root 3. And you might not recognize that value, because on your pi plate you have root 3 and you have root 3 over 3. Okay? But if you rationalize the denominator here, that's the same as root 3 over 3. So sometimes you have to do a little bit extra work so that it does look like something on your pi plate. The fact that this is a non-calculator question is hinting, it's hinting to you that yes, that value should be something that you know. What family is that? Pi over 6 family. It's going to be in quadrants 2 and quadrants 4 because it's negative. So these are all questions that we did in chapter 6. And in chapter 6, we mainly looked at solving between 0 and 2 pi. Sometimes it was between negative 2 pi and 2 pi. Sometimes it was in degrees. And what we're going to get introduced to today is solving not just between 0 and 2 pi, but this same question, part D, could look like this. Solve for theta, root 3 tan theta plus 1 equals 0, where theta can be any real number. So we're not just looking at once around a circle or twice around the circle or once positive, once negative. We're looking for every single possible answer. And so the way that we're going to write our solution is we're going to say to ourselves, well, 5 pi over 6 and 11 pi over 6, if I draw those as a picture, 5 pi over 6 is over here in quadrant 2, 11 pi over 6 is over here in quadrant 4, and I'm going to need to have every single angle coterminal with those forever. So how do I write that? Well, it's the same way that we wrote coterminal angles before. You're going to say theta is equal to, you can list them both separately, 5 pi over 6 and 7 pi over 6. And how do we write coterminal angles? We add, thank you, 11 pi over 6. We add 2 pi times k as many times as we want. Now, as we do this more and more, mathematicians like to write the pi at the end, so that ends up, instead of 2 pi times k, often write it as 2k pi. That means exactly the same thing. If you like to write the k at the end, it's not wrong. But I'll start writing it as plus 2k pi, where k is an integer. So we're going to start writing general solutions by saying we can take our answers and write all the coterminal ones of 5 pi over 6 by adding 2k pi. And we can write all the coterminal angles with 11 pi over 6 by adding 2k pi, where k is an integer. And this will be the format that we can write it. And this will be a correct answer. Sometimes in multiple choice questions, especially with tan, they might even write this answer in a different way. They might say, do you notice how far it is between each of these answers? 180 degrees or pi. So if you didn't want to do 5 pi over 6 plus 2k pi, because 5 pi over 6 plus 2k pi will just get all the ones that end here. And 11 pi over 6 plus 2k pi will just get all the ones that end here. If you wanted to get them all at once, another way that you could write this one, and sometimes you'll see this in multiple choice questions, they'll say it's just 5 pi over 6, and then if I go around only pi as many times as I want, where k is an integer, that will start here. Go halfway around, get this one. Go halfway around, get the next one. Go halfway around, get the next one. And get all of the coterminal angles that way. Yes?
Would they do it with 11 pi over 6 as well?
You could choose either one of those as your starting point. So whatever you put here, you could choose either the 5 pi over 6 or the 11 pi over 6, or any coterminal one that you wanted. So this is a little bit more elegant, but this is more what you would expect to write, because it's easy. In fact, this is our first new big idea. So if you turn to page 574, at the top of page 574, we're going to write these instructions. These are the steps for solving the general solution. Step 1, you're going to solve it like normal, as if it was just from 0 to 2 pi. That's what we did in that question before to find 5 pi over 6 and 11 pi over 6. You solved it just like normal from 0 to 2 pi. Then once you've solved it, to each of your answers that you have from 0 to 2 pi, you're going to add 2k pi, where k is an integer, because then you'll list every single coterminal angle with those angles. And these will be our steps. So this is what's new to Chapter 7. You won't have general solutions on your Chapter 6 test, but step 1 is what you're doing in Chapter 6, solving like normal. So the reason we're doing it is because it practices what we've done in Chapter 6 so far. So at the bottom of the page, we're actually not going to do example 1. If you want to put an X through it, we're going to do this example 1 instead. And we're going to solve for theta, where theta is a real number for 7 sine theta plus 1 equals 0. So as far as our starting place, we start by solving this just like normal from 0 to 2 pi. How would we solve this for normal from 0 to 2 pi? Well, we'd get sine by itself. We'd find our reference angle by doing sine inverse of positive 1 over 7. Once we've got our reference angle, we'd say sine is negative in quadrant 3 and quadrant 4. And we'd get 3.28 and 6.14. So that's solving normal. That's step 1. Step 1, solve like normal between 0 and 2 pi. Step 2, take each of your answers and add 2k pi. So how do we write that? We take each of our answers plus 2k pi, where k is an integer, and this is the format that we would write it in. So 2 ways that you can have a question that's asking for the general solution. We saw in our first example, I said theta ER, or theta belongs to all real numbers. The question can also have just find the general solution, like this one. So if you have either those 2 ways, theta belongs to all real numbers, or find the general solution, that means you have to solve for everything. There was one provincial exam, I don't know, it was like 8 or 9 years ago, where it just said solve for theta, and it didn't say general solution, and it didn't say theta ER, but it didn't say between 0 and 2 pi. And it was determined on that exam, if they don't say, you have to solve for the general solution. But now, since a number of students didn't know that they should solve the general solution, they're much clearer on the final exam. And they'll either say general solution or give you the domain that theta belongs to all real numbers. Oh yeah, I'll put the answer up in a bit. So I'll put up the answer here so you can be checking. It's just the answer, none of the work.